Hello everyone. In this session, we will start the Pentium architecture. We'll start understanding about the Pentium architecture. When it comes to the Pentium, it is the brainchild of the Intel Corporation. You know that the Intel is one of the biggest manufacturer of the computer chips. Those are the processors. Of course, it's the most successful company in designing the processors. Right from 1960s till date, till 2021, has been the leading chip maker in the industry of the computers. Let us see what is the architecture and what are the things that are associated for a Intel processor. And we'll try to learn the design perspectives of a processor. Let us start understanding. At the end of this complete chapter, you will be able to understand the Pentium family history and the Pentium processor details, how the processor has been designed, and what are the different register set that is available in various Pentium processors, in which what are the data registers, what are the pointer and index registers, the control registers, and the segment registers. You know that the computer system is going to be operated in two different modes. One is user mode and one more is protected mode or supervisor mode. And here, when it comes to the Intel, what are the different modes that are going to be used? You're going to understand. Namely, the real mode and the protected mode memory architectures we're going to understand. Now, when it comes to the memory, in order to address memory, we need to have several segment registers, segment descriptors, segment descriptor tables, and segmentation models we need to understand. All those things we'll have an overview. And in addition to the two-mode operation, some advanced Intel processor supports more than these two modes. Generally, a processor operates in two modes. One is user mode and one more is the supervisor mode or protected mode, whatever you call. But some processors supports more than two modes, in which case the processor supports the third mode, and everything we're going to understand. And what are the different default segment registers used in various processors also we're going to understand. Let us see. The first processor that was introduced by the Intel was way back in 1969. In 1969, Intel designed a processor which was called 4004. This 4004 was a 4-bit microprocessor. When you design a microprocessor, when you look at the configuration, you will get it could be either 4-bit or 8-bit or 16-bit or 32-bit or 64 bits. Nowadays, in the recent days, architectures are anywhere in between 32 to 64 bits. But the first processor that was designed by the Intel Corporation was 4004. This 4004 is a nibble processor. What is a nibble processor? Nibble processor is a 4-bit processor. Once again, we need to understand what is this bit and how the manufacturer of a processor is going to decide either it could be a 4-bit or an 8-bit processor or a 32-bit processor. This 4-bit or 8-bit, whatever you call, when a processor is designed by using some specific bits, it does mean that the processor supports a word which is equal to the architecture length. A 4-bit processor architecture size is 4-bit. That is, a 4-bit processor supports a 4-bit word. A processor can read and process a 4-bit data at a time. Our bus system also should support a 4-bit data. Let me give you some brief idea about this. Let us go to the main memory. You know that main memory is going to hold all the programs. When you talk about the architecture size, either it could be a 4-bit or 8-bit or 16-bit, it is actually telling you that one word size in the main memory. one word size should be equal to 4 bits if it is a 4-bit processor. If it is an 8-bit processor, one word size in the main memory is equal to 8 bits. Similarly, when it comes to the processor, because all the programs are going to be residing within the main memory, and these programs are going to be processed by this processor by executing the instructions one by one, right? So here, what is the size of one word? One word is equal to 4-bit, let us say. Okay, when a 4-bit word is going to get transferred to the CPU should have a provision to store the word which is accessed from the main memory. So obviously, CPU should hold a few registers. You know that the registers provide you the storage provision within the CPU. The words that are accessed from the main memory will directly get transferred to one of the registers, such as the address part will go to the program counter, the instruction will go to the instruction register, so on. So here, the processor should accommodate a few registers when the data gets transferred from main memory to the processor to accommodate that specific data. So here, when processor accommodates a register, the processor should specify the size of that register. Size of the register should also be equal to 4 bits because the computer word size is equal to 4 bit because the architecture size is equal to 4 bit, right? So the first processor that was designed by the Intel was 4004. The 4004 is the 4-bit processor, which means that one word size in the main memory and one register size within the CPU is equal to 4 bits. Right after 4004, next edition of the Intel was 8080 and 8085. These both are 1-byte processors. What do you mean by 1-byte processors? 1-byte processor meaning one word size will be equal to 1 byte. That is, one word within the main memory or the size of the register within the processor are equal to 8 bits. That is equal to 1 byte. So let us understand that these three were in the market just before the invention of 8086. Of course, these were pretty much successful processors before the invention of 8086. Before the invention of the 8086, the market was completely invaded by 8085 because among these three, 8085 was the most successful processor because of the architecture flexibility. Now, this 8085 didn't last for much time because right after the invention of 8086, the people got habituated and used to 8086 because of the flexibility that 8086 imposed in the processor in it. The flexibility that have been developed and that have been given to the programmers looking at those aspects. All the programmers are decided to replace their processors with 8086. This 8086 was introduced in 1979. It was the year changed everything. Right after 8086, the computer system has been made available even for a normal user. In every household, you started seeing a computer system because of the powerful architecture which is designed for an end user directly rather than a programmer. All these processors before 8086 were designed to give the flexibility to just the programmers. But right after the 8086 has been developed, designers of these processors started focusing on an operating system that can be exploited even by an end user. Before 8086, the person who uses the computer must only be a programmer. But right after 8086, Windows developed one operating system that is called MS-DOS. MS-DOS is a very flexible operating system that even an end user, a normal user, can operate the computer system with so much efficiency. That is the reason why 8086 is considered to be the mother of all the architectures, because 8086 made the computer system available even for an end user directly. It doesn't need the intervention of a programmer. This 8086 is a 16-bit processor. Just before the 8086, we just have only 8-bit processor. But right after 8086, we started having 16-bit processors. That is, one data word is equal to 2 bytes. The memory, in the memory, 2 bytes are collected together and organized as one word. Okay, and 8086 provides a 20-bit address bus. What is this 20-bit address bus? This address bus talks about the addressing convention to the main memory. If I do have a 20-bit address, I will be able to address a total of 1 megabyte main memory. Because by using 20 bits, the maximum address length that can be constructed is 2 power 20, right? 20 bits meaning in an address we do have 20 bits. So the first address will be 20 zeros. Final address will be 20 ones. 20 ones will be equal to 2 power 20, which is equal to 1 MB. That is, 8086 can support a total of 1 megabyte main memory. It will be able to address 1 megabyte main memory. How the main memory was going to be addressed in 8086, you can watch my previous videos on 8086. Yeah. 8086, after 8086, there was a processor which is 8088 was developed, which is the less expensive version of a 8086, because 8086 is proven to be costlier. But when you talk about a household computer system, it requires a processor which is less expensive to make it available even for a normal user. So an 8088 was developed, in which the data bus size has been reduced to just 8 bits. But still, the memory, the total memory that is available for even 8088 is 1 MB. Let us try to understand the difference between 8086 and 8088. 8088 is an extract version of 8086, but it is not a simplified version. It is an extract version. All the features of the 8086 have already been have also been incorporated to 8088 with a minute changes to make it more flexible and less cheaper. In 8088, you need to understand that the data bus size was 8 bits. So is the address bus size was 8 bits, which means that one word is equal to 8 bits, but not 16 bits. And the address bus has 4 different parts, in which total 20 bits would be calculated to address a total of 1 MB. And next, it can address up to 4 segments of 64 KB. You know that 8086 main memory has been divided into various segments. A total of 4 segments are available in 8086. All those 4 segments can be effectively addressed by using 20-bit address. Okay, and the mode in which a programmer does work is referred to be as a real mode. What is the real mode operation? Real mode is operation is just nothing but the operation in which a programmer is going to use the computer system, which is called the real mode. Yeah. Right after 8086, we do have 80186 processor. 80186 processor is simply it's the 8086 processor. Of course, it is equal to, let me tell you, it is equal to 8086. But it's a faster version. Still, of course, the data bus size was equal to 16-bit because we do have a 16-bit data and we do have a 20-bit address. There is no change. But the number of instructions that were supported by the 8086 are far lesser than 80186. You know that the complexity of the processor have been defined by the number of machine language instructions that have been adopted to that processor, by that processor rather. So 8086 uses a few machine language instructions. 80186 use far more machine language instructions than 8086. You know that when you design a processor, essentially you need to design three things. One is the register set, second one is control unit, and the third one is ALU. In addition to these things, you should also design a few machine language instructions. It can be called as instruction set. After designing these physical entities, those are register set, control unit, and ALU, you should be able to design one instruction set which contains the machine language instructions that are supported by that processors, and you should be able to implement them in the processor. That is, you need to embed these instruction set into the processor. Then your processor becomes the processor that can be used in a computer system. The size of this instruction varies from processor to processor. 8086 instruction set has the limited number of instructions, but when it comes to the 80186, we do have far more number of instructions than 8086. Here, it will be more faster. I'll tell you the difference between using less number of instructions and rather, more number of instructions. When you use less number of machine language instructions, every high-level language instruction, that get translated to a few of machine language instructions. Let us say I do have a printf instruction. When you execute printf, there will be a set of corresponding low-level language instructions will get executed. If your processor supports only a few instructions, the number of instructions that support printf, rather, any machine language, any high-level language instruction, bigger pardon, will be more. I need to execute a lot of instructions, lot of machine language instructions for executing one high-level language instructions. But when it comes to a processor which uses more number of instructions, for every high-level language instruction, there will be only one mapped low-level language instruction. I hope you got it. That is, every time when you execute one high-level language instruction, the corresponding some low-level language instruction should get executed, right? This is the difference. Being a designer, if you use a limited number of machine language instructions, altogether only those machine language instructions should be used and translated to for executing every high-level language instruction, right? But if you use a vast number of machine language instructions, being a designer, you take a necessary precautions and care such that every high-level language instruction will have an equivalent one and only one machine language instruction to execute. Sometimes maybe 2 or 3, but not a set. In this case, the programs will get executed more faster. Executing a simple high-level language instruction, if you execute a few number of instructions, of course, it takes a lot of time. But if you have to execute only 1 or 2 in machine language instruction for every high-level language instruction, of course, the time will get reduced, right? That is improved instruction set, which also improves the time of a processor so that the throughput can be effectively increased. The next version is 80286, was introduced in 1982. What is 80286? 80286 is just an updation to 80186. It's a 24-bit address bus and 16 MB address space. You know that 8086 provides you only 1 MB address space. You know that the main memory is the memory that is going to be used by the programmer. Any program that you're going to execute should be accommodated within the main memory. Using only 1 MB main memory obviously limits the resource of the system to accommodate more number of programs. So the designer of this 8086 looked towards as developing a system which can support more main memory. So they went for 80286. In 80286, the total main memory is of 16 MB. In order to supports 16 MB. The address size must be equal to 24 bits. Of course, 2 power 24 is equal to 16 MB, isn't it? Of course, enhanced with the memory protection capabilities, the protection of the memory is enhanced in 80286. Introduced protected mode. Here we are. In the previous 8086, there is no protected mode. Generally, the system operates in two modes. One is user mode and one more is supervisor mode. Here, everything was in real mode. What is the real mode? Real mode blends both user mode and supervisor mode. But here, there was a distinction between user mode and a protected mode. When the user executes a program, the computer system is said to be in the user mode. But when a user or a programmer uses the resource of the computer system, immediately that would get transferred to a protected mode. Rather, the mode will be switched to a protected mode. Backwards compatible. What is backwards compatible? Let us understand carefully. Generally, when we design something, we are going to deploy something called forward compatibility. Let us say I designed something. On this day, I designed a processor. The processor that I designed, of course, acts as a mother of all the processors. After which, whatever the advanced versions I develop that are going to be deployed on the same instruction set, rather same compatibility with the processor that I designed. Mean to say, let us say I have designed one processor X. After X, I design Y. X to Y, this is a forward compatibility. The Y is going to inherit the features of X, and also it has its unique features. But when I design X with a backward compatibility, the X will also inherit the previous versions of it. Generally, when you design Y, the Y will, as it is forward compatible, it is going to use a few features of X, and the X will remain the mother processor. But when X is backward compatible, this X can also inherit the features of the previous processor. This is called backward compatibility. If a processor is designed to be backward compatible, it can also inherit the previous processor, its ancestor. Here, Y is also backward compatible, mean to say. And 80286 is a backward compatible processor. And next one is 80386, which was introduced in 1985. It is the first 32-bit processor. It was the first 32-bit processor. And 32-bit data bus and 32-bit address bus. And the total main memory that can be supported is 4 GB. 4 GB is not available, let us say. The maximum main memory that can be supported by 80386 was 4 GB. So the user can choose from 1 to 4 GB of main memory. He can start with 1 GB and he can update it to 4 GB even. Okay, segmentation can be turned off, flat mode. That is, main memory initially will be segmented as 8086. But when user doesn't want these segments, he can completely turn these segments off to make this entire memory as a single segment. In 80386, 80386 is the first processor to introduce the concept of the virtual memory. In virtual memory, we use pages. The concept of the pages has been initiated by 80386. After 80386, we do have something called 80486. 80486 was introduced in 1989. It's just simply an advanced version of 386 in which combined processor functions for performing floating point arithmetic. You know that the advanced computer system supports floating point architecture. It's not a fixed point architecture. The difference between floating point and fixed point we discuss in number system. This 80486 supports the floating point arithmetic. added parallel execution capability to the instruction decode and execution unit. This is the first processor to support pipelining. The concept of the pipelining has been adopted and utilized initially by 80486. It was the inventor, or rather deployer, whatever you call. It was the first processor to use the concept of pipelining to speed up the execution of the instruction, thereby getting more throughput. Achieve a scalar execution of one instruction per clock. When clock ticks, rather, for one clock cycle, this 80486 is capable of, rather was capable of executing one instruction. Later versions introduced energy savings for laptops. This is the thing with 80486. Next, we are going to discuss about Pentium processors. These Pentium processors, right from 1993, actually ruled the era of the computing. You know that before the Pentium, we didn't have any computer system, actually, mind you. We owned the computer system right from Pentium architecture. And the Pentium architectures are the fastest architectures. Whatever the processors that we're using, of course, are based on Pentium architecture. Of course, when you track backward compatible, when a processor is backward compatible, of course, your processor does show a few resemblances of 8086. But still, 8086, you need to understand, it's a 16-bit processor. But all the processors, nowadays processors are either 32-bit processors or 64-bit processors. So all these processor architectures, what we're using, are going to inherit Pentium processors. This Pentium, the first Pentium processor, has been called as the 80586 processor, which was introduced in 1993. About this Pentium processor, I'm going to give you an overview in the next session. Thank you.